Okay, we're back on part 4, and now we're at a point where we can do whatever we want. We can solve by any method. We could graph if we wanted to, we could do elimination, or we can do substitution. Again, I'm going to use what I like the best, and in this case, what I'm going to do is I'm going to do elimination. And now I see that those are opposite signs, and is there any way I can make and get rid of the y's? Well, if I multiply this equation times 4, that would give me 8y. Minus 8y is 0, so that's what I'm going to do here. So I have 6x minus 8y equals a negative 0.6, and if I take that times 4, that gives me 12x plus 8y equals, and that's going to give me 3.6. All right. Well, those cancel, and then I have 6 plus 12 is going to be 18x. 3.6 minus 0.6 is 3. Okay. Well, guess what? We're going to get a fraction here, but that's okay. And so x is equal to 1 over 6. Oops. There we go. So x is 1/6. All right. So now what we have to do is we have to plug that back into one of the equations. Well, maybe I'll plug it into that one because if I do that, then I'll have easy number to do. 6 times 1/6 is 1. So let's plug it into there. So 6 times 1/6 minus 8y equals negative 0.6. So 1 minus 8y equals negative 0.6. So I'll subtract 1. And so I get negative 8y equals, and now I get a negative 1.6. Well, if I divide by negative 8, then y is equal to, well, if I think about that, I'm taking 8 into 1.6, so that's going to be a 0.2, and that will give me what I have. And 2/10, if I want to rewrite this as a fraction, is going to be 1/5. And so I get 1/5 for my y value. Okay. So I'm saying my solution is 1/6, 1/5. And so now I have to check to see, is that really true? Well, 6 times x, which is 1 over 6, minus 8 times 1 over 5 uh, is going to be equal to negative 0.6. And on the other one, I'm saying 3 times 1 over 6 plus 2 times 1 over 5 is equal to 0.9. All right, so here we have 1 minus 8 over 5 equals negative 0.6. And so now if I get a common denominator, that's going to be a multiplied by 5 over 5. So I have 5 minus 8, so it's minus 3 over 5 equals negative 0.6. Well, here again, if you don't know your division, 5 goes into 3, and it's going to be 0, and that's going to be a 6. And so I get a negative 0.6 equals negative 0.6. So that works. Now 3 divided by 6, that's going to be 1/2. And then I have plus 2/5, and that's supposed to be 0.9. Well, here I'm going to have to multiply by 5 over 5, and this one by 2 over 2 to get a common denominator of 10. So I have 5 plus 4, that's going to be 9 over 10. And 9/10 is 9/10, and so that one's easier. And so that is my solution to this system of equations. And again, we had a little bit more work on this one because we ended up with fractions, and we had to think about, going and dividing decimals and then also converting fractions back to a different fraction. So there's a little more work to do, but it's still not that hard to do. All right, what about this one? Well, this one, I think I want to get rid of fractions. So I'm going to multiply both equations by the common denominator. And so what is the common denominator? Well, the top one, we have 12. The bottom one looks like 2. Okay, so if I take the top one by 12, I'll have 12x minus 5y equals negative 55. So that doesn't look too bad afterwards. And this one, if I multiply that, that's going to give me negative 12x. And then plus 5y is equal to, and that's 55. Is that correct? It looks to be. And so guess what? That cancels that, that cancels that, that cancels that. So I get 0 equals 0. That's true. So it's going to be infinite number of solutions. And remember, when we do that, we want to have x comma and then whatever y is equal to. So we have to solve one of these for y. Let's solve the second one. So let's say we have negative 6x plus 5 over 2y equals 55 over 2. And so we'll add 6x. So we get 5 over 2y equals 6x plus 55 over 2. So now I have to multiply everything by 2/5. So I'll multiply that by 2/5, multiply that by 2/5. All right, so then I get y equals, well, 2/5 times that, that's just going to give me 12 over 5 x. And, well, here, 5 will go in here once, and it'll go in here 11. 2 will go in here once, that'll go in here once, plus 11. So it turns out not to be too bad. It's 12/5 x plus 11. And so then that would be my kind of general form of the solution, where I plug in whatever x, and then I get out the y, and that's going to be the solution to this system of equations. All right, what about this one? This one we could go either with x's or y's, because we could go here and eliminate the x's by taking one of them by 2, the other one by -3, or vice versa, however you want to do the negatives. And we could get this one to 12s, and so we could do that. Again, I don't know which one is easier, so let's take the first one times maybe, let's do the negative on top, -2. So that gives me a -6, and if I need a +6 here, I have to multiply by 3. So that gives me -6x minus 12y equals -22. Here I'll get 6x plus 12y equals 27. Well, that cancels that. That cancels that. So I get 0 equals 27 minus 22 is 5. Well, that's false. So there, so there's going to be no solution. Okay, so a simple system looks easy, but there's no solution. So again, what that means is we had two parallel lines. Now, if they were up or down or left or right, I'm not going to go with that. I'm just showing you that they're going to be parallel lines some direction, okay? All right. What about this one? Well, here we have decimals in both of them. So, before we just had decimals in one and we multiplied that equation by something to get rid of the decimal. Well, this one I'm going to multiply both of them by. And so I'm going to multiply the top one. This is 10th and this is in a tenths. So I'm going to multiply the top one by tenths. Well, here this is in the hundredths. This is in the tenths. And so I'm going to multiply the second one by 100. Okay, and that way I move the decimal 2 to the right, and this one I move it just 1 to the right. So the top one I'll get x plus 2y equals 20. The bottom one I'll get 35x, and then it's going to be minus, and then we have 100, so then I'm going to have 30y, and that equals 0, because 100 times 0 is still going to be a 0. All right. Well, now I could multiply this one by 15, but we're getting big numbers here. So I notice I have x here. So I'm going to solve this equation for x, and I get x equals a minus 2y plus 20. So I'm just going to subtract 2y from both sides. And then I can take this and plug it in here and solve for y. So sometimes I will do substitution if I see that, if I do it the other way, I'm going to have to multiply by big numbers. And if I did the other one, I'd have to multiply this by a negative 35, and that's even bigger than multiplying by 15. All right, so 35 times negative 2y plus 20. Guess what? We still have to multiply 35 times 20. So it didn't save me anything here, but that's okay. Minus 30y equals 0. So here 35 times 2 is going to be minus 70y plus, and that's going to be 700. And then we have minus 30y equals 0. So I can add those two together. If I subtract 700 from both sides, then I get minus 100y equals minus 700. And so divide by negative 100, and y equals 7. So it turns out not too bad. So I get my y. And now I'm going to plug that in here and solve for x. So minus 2 times 7 plus 20. And so it's a minus 14 plus 20, and that's going to give me a 6 for x. And so I'm saying my solution is 6 comma 7. Okay, so now I have to check. Now you actually have to check back into your original equations again. And so we have 0.1 times 6 plus 0.2 times 7, and that's supposed to equal 2. And here we get 0.6 plus, and this is going to be 1.4. And so then we get 2 equals 2. So that one works. And here we have 0.35 times 6, and then minus 0.3 times 7, and that's going to be 0. Well, 35 times 6, that's going to be 30, 18, 19, 20, 21, and move the decimal 2, so that's going to be 2.1. And then minus, well, that times that's going to be 2.1, 1, and that equals 0. Well, 0 equals 0, that works. And so then that is my solution. Okay, so that's the end of part 4. I'll come back with part 5.